Hey, General Math, we are starting on chapter 5 today. We have divisibility or number theory. So we've talked about natural numbers before. That's just like how we count on our hands: 1, 2, 3, 4, 5, 6, and so on. Every single counting number, every single natural number can be classified as either a prime number or a composite number. So there's two different types of natural numbers. A prime number only has the factors of 1 and itself. And factors are numbers that divide that number evenly. So if you take a look at like 13, so 13, you can't divide 13 by anything and have it come out as a nice number, except for like 13 divided by 13 and then 13 divided by 1. So since it's only nicely divided by 1 in itself, it's a prime number. Now, composite numbers, on the other hand, they have more factors than just 1 in itself. So let's take a look at 6. So 6 can be divided by 6 itself and 1, because 6 divided by 6 is 1, 6 divided by 1 is 6. Those are both not nice numbers. But it could also be divided by 2. So 6 divided by 2 is 3. So that's another factor. It could also be divided by 3. So 6 divided by 3 is 2. So it has more factors. It has more numbers that can divide it nicely than just the number 1 and itself. We kind of have a little key here. So like 1 is a prime number because it's only divisible by 1. 2 is a prime number because it's only divisible by 1 and itself. Same with 3. But 4 would be composite because it's divisible by 1, 2, and itself, and so on. You can kind of look through that list. But notice that 2 is the only even prime number because all even numbers are divisible by 2. But 2 would be prime because if we divided it by 2, that's dividing it by itself. And then we have some shortcuts down here to make it easier to determine if the divisibility of a number. So if a number is divisible by 2, if the last digit is even. We kind of talked about that before. For 3, to see if a number is divisible by 3, we add up all the digits. So if we have the number 357, it is divisible by 3 because we're adding up 3, 5, and 7. 3 plus 5 plus 7 is 15, and 15 is divisible by 3, which means 357 is divisible by 3. A number is divisible by 4 if the last two digits of the number are divisible by 4. So even though we have this great big number right here, we're only going to look at the last two digits, 48. 48 is divisible by 4, so the whole thing is divisible by 4. We just kind of go on, just kind of summarizes the rest. We have the numbers 2 through 12. So if you're trying to find out if some really big number is divisible by one of these numbers, this is kind of your key. This is kind of your shortcut. Lastly, we say a smaller number is a factor of a larger number when it divides it evenly. We've kind of talked about that before, but just to kind of clarify, so the factors of 16 are 1, 2, 4, and 8, because I can divide 16 by 1, 16 by 2, 16 by 4, 16 by 8, and it'll all come out to be an even number. And then just some notation. When we see, for example, like 8 and then this vertical line, n, we read this as n is divisible by 8, or 8 is a factor of n. You can see that right there. So if n is divisible by 8, then n is divisible by 1, and n is divisible by 2, and n is divisible by 4, because if 8 goes into this number, and we don't know what the number is, right? But if 8 goes into this number, we know that 1, 2, and 4 go into that number as well, since 1, 2, and 4 go into 8. They're just smaller. They're factors of 8. So if 8 is a factor of something, 1, 2, and 4 are also a factor of that same number.